Welcome to a new video. In this video, I will start a new series in looking how to manipulate servos, not via Bitwango like in my other playlist, but in this case via a simple interaction with a microcontroller of type ESP8266 or ESP32 and the servo directly connected to the microcontroller. This is not a scenario that I would recommend for complex movements. It is more for simple things. In my case, we will end up with using two servos that will drive in different directions to open and close the face shield of an Iron Man mask, which is not part of a bigger installation, but just something that I want to have sitting up in my shelf. And that's what I feel the ideal solution to use something more simple like ESPHome. The other benefit of ESPHome is that it integrates very nicely with home automations like Home Assistant. So you could maybe play around and have your servos interact with events that happen in your smart home, or you can connect it to your Home Assistant based home voice assistant. So there are many ideas that we can explore in later videos. As many roads lead to Rome, there are also many ways how to start with ESPHome. If you have a Home Assistant installation, you can maybe skip some of the steps that I'm describing here and just install your ESPs directly via your Home Assistant installation. But for those that don't make use of Home Assistant yet, I'm going to walk you through how to manually install ESPHome. And let's start by going on the ESPHome home site, on which you will find the Getting Started section. You will see there is an instruction for getting started from Home Assistant and getting started using the command line. And what we will do is click on the using the command line. Here again we're offered options. One is using a really manual installation, the other one is using additional technologies like for example Docker. To keep things simple, we will do a manual installation. At this point, it's important to note that I'm running everything here on a Mac. It is very similar if you want to run it on Windows. So let's open up a command line interface. As you can see here by the instructions, Python needs to be installed, and I'm pretty sure that I have Python already installed on my machine. So I'm just going ahead to start installing the additional components with wheel as the first one, which already exists on my system. So next thing is to install ESPHome via pip. And this should also work without any issues. As you can see from the yellow warning, my local path variable, so the path in which the command line looks for executable programs, does not include the Python bin library. So what I already did is I added my Z profile file on my Mac to include the library or the directory pointing to the binaries of Python. And to activate it, in this case, I'm just running the source command with the .z profile file, which should read the file, change the path variable. And as you can see, if I just now type ESPHome, it's found and we are ready to go. So for some reason, my recording when I created my directory and prepared everything to run ESPHome got lost somewhere. So I'm just going to show you here on this screen what I did. So I went into my documents folder, I created in there a new directory called ESPHome, and in ESPHome I also created a config directory. With both these directories present, I was able to start ESPHome. As an argument, I said dashboard and config, which means that I want ESPHome to run its inbuilt web-based dashboard capability, and that he should use the newly created config directory as the target for all configuration files that he's going to create in the next steps. And as you can see in the last command where I started ESPHome, the green answer from the command line gives us the URL or the web address that we can now copy and paste into our browser to access our locally running ESPHome dashboard. We're now ready to add a new device to ESPHome, but before we do that, please make sure that you have an ESP8266 or an ESP32 connected via USB cable to your computer. Otherwise, the next steps will fail, because how should we add a device that doesn't exist? Let's now click on New Device to add a new device. Go on Continue. Give that device a name. In my case, I'll just call it Single Servo, because we will just connect a server to it. And give your network credentials for the wireless network at your home that you want to connect. Select what type of ESP you have, just acknowledge the passkey and install. As you can see in the dialog, there are various ways to install the code onto your microcontroller. From wireless, which we will do maybe in a later step, manually, or via plugged into the computer running ESPHome dashboard. And this is exactly what we've prepared. We have ESPHome running with the dashboard locally on the same computer. We have via USB cable connected our device. So this is what we will select. And then you can see in the log how ESPHome is compiling the code, creating the binary, and then copying the binary via cable onto your ESP. When the code is ready deployed and the ESP rebooted, you start seeing the log messages from the ESP. In my case, I sometimes have to manually scroll in that window to see the log output. But at the end, after everything runs, you should see something similar to what you're seeing on my screen here, with your ESP reporting that he's connected to your local Wi-Fi that you configured. What you also see is lots of warning messages that are normal, because your ESP wants to connect per default to your ESPHome instance, which we will not make use of at the moment. But it will give us a chance to look at how to change the code on our ESP. For this, stop the output, click Edit, and then in the source code you'll find a section called API with some subsections. This is for your ESP to connect to your Home Assistant instance. Just put the pound as a comment sign in here so that it's commented out. And once we are already in the code, let's also change the board to the ESP board that you're really using. In my case, I'm using the Vimos D1 Mini as the physical ESP board. With the changes done, click on Save and Install, and again plugged in via this computer, and let ESPHome reinstall the new updated code onto our microcontroller. With the new restart of the microcontroller, those annoying warning messages are gone, so we can stop looking at the logs, and we can also leave the source code of our single servo. Let's recap what we've done so far. We've installed ESPHome, we flashed a default, very empty firmware onto our microcontroller, we changed the source code to get rid of those annoying messages, reinstalled our firmware onto the microcontroller, but it's actually not doing anything yet, and we have no way of interacting with our ESP microcontroller. Luckily, ESPHome is really capable, and the ESPs as microcontrollers are really powerful. So what we can do is enable a web server on each of the microcontrollers so that we can interact with the ESP via any browser that is in the same network or can access our ESP. For this, we need to edit the source code of our single server, and at the bottom of the source code we'll add a simple statement saying web_server and then the double points. Once that's done, save and install as previously done, and just wait for the updated firmware to be compiled and uploaded onto your ESP. Now, after the restart of the ESP, and please keep in mind that you sometimes have to scroll down in the log window to see everything, you should in the log entries see the IP address of your ESP. And this you can use now to connect via a browser to your ESP. And if your local network allows, you can even use the manually created dynamic host name that was created and add it to your network. So copy that information, open a new tab, go onto your ESP, and then you can get some response, and you see that he's really alive and kicking. We've now reached a point where we can move away for a minute from the software side and just deploying code on the ESP to look at the wiring that is required to connect a servo to your ESP. In this screen I'm showing you a very, very simple version of how I did it for test purposes. Maybe in a later video we'll discuss on how to add external power sources to power up the ESP and the servos independently from each other, but I'm also expecting some level of pre-existing knowledge. If that expectation was too much, just drop me a comment and I will see if I can create something quicker for you to get that knowledge. So what are we looking here at? We have my ESP8266 is a D1 Mini. There are various versions out there, but they're more or less very, very similar. So the connection is very straightforward. The red power cable of the servo is connected with the 5-volt pin of my ESP, and the brown ground wire of the servo is connected to the ground pin of the ESP Mini. To receive signals on how to move, the yellow cable, in some cases it's orange, and my cable here is yellow, is connected to the pin D1 of my ESP. As the ESP gets its power from the computer via the USB cable, no additional wiring is needed at the moment, and as planned, pretty simple and straightforward to give you a look into the basics. So now let's go back into the source code of our servo so that we can tell him what he needs to do with this physically connected servo. For that, we jump to the end of the source code, so the section under web server, and we have to add a few sections in here that we will discuss. So first thing that we need to do is add the output section. In output, we have to define what kind of platform we're using, ESP8266 in this case. We have to give our output a unique identifier. In this case, I just used it, called it PWM output. We have to define the pin that is connected to, and very importantly, we have to define the frequency that the ESP is supposed to use to interact with the servo. The next section is the definition of the servo, because ESP needs to know that there is a servo. We give it a unique identifier, servo underscore number 1 in my case. we have to define what kind of output the ESP is supposed to use to interact with the servo. So it's PWM_output. And then we can add a few more parameters. In my case, I changed the auto detect time to 5 seconds. With me, it's after the movement of the servo has been done. After 5 seconds, it'll power off. And transition length, 0 seconds, defines how fast the servo is supposed to move. In my case, as fast as he can. Now we have to define our scripts, which are the actions that the servo is supposed to do. I'll just run through the first one because the other ones are straightforward and really the same as the first one. So we give each script a unique identifier. In the first script, it's open servo script. And under the then section, we tell the script what to do. So we're expecting him to write something to the servo, to servo number 1, and we want him to move to 100%. So that's a movement of the servo fully into one direction. And then you can see where the others, like mid servo script goes to 0 and close servo script goes to -100. So we have 3 scripts that we can use to move the servo from one full swing to the other full swing or to a middle position. Now that we have actions for the ESP to do on the servo, we somehow need a way of telling the ESP when to perform such an action. And for this, we will add buttons, virtual buttons to our ESP. And again, I will run you through the first one as an example. The other ones are straightforward. So under button, we have to define a platform that we need to use for the button, and please use template as shown here. Then we can give each button a human readable, meaningful name. You can write whatever you want. Like in my case here, the first one says servo to 0 position. Then we have to give that button a unique identifier, servo to 0. We can define an icon that will be used in the web URL and the dashboard of our ESP. And we can define that what needs to happen. So in this case, on the on press event, so if this virtual button is pressed, then execute the script close servo script. That's one of the scripts that we implemented before. And as I said, straightforward with the others. If we want a button to move to the middle position, then we call it something with middle position, and as a script we will then call the previously created script with the unique name mid servo script. And the same for close. With all the code changes done, all we need to do is again save and install the new and changed firmware onto our ESP. When you now return to your browser and connect to the ESP, as we've done in the previous step, you'll see that the UI of the web page from our ESP has changed. So we're now seeing our 3 buttons with the names that we defined, and we also have some more output on the log screen. So now let's press a few buttons and let's observe what our servo is doing. So this was already nice, but what if we don't have predefined positions that we want our servo to go to? What if we want to have a more dynamic way of setting the position of the servo? Well, I wouldn't address this if there wasn't a way to do it. So let's jump back into the source code. For this, we just click Edit. We'll go all the way down to the end of the code that we have programmed so far, and we will add a new section under our scripts. This new section is called number and represents a number on our ESP and ways to interact with that number. I would just recommend you to copy the code, and it's in the links in the description of the video. You find the link to the entire source code, so no reason to write and copy from screen. And by now you should be able to make heads and tails out of the different sections of this code segment. The only interesting thing maybe is the lambda part on the very last line, but that's not to worry about. That's just some calculations on how to change the number to a number that the ESP can make use of. Let's save and install the changed code again and push it onto our ESP as you've done it already a few times. When you now go back onto the web UI of your ESP and refresh or reload, you'll see a new action, which is a slider for the representation of the number. And if you move the slider, guess what? Our server is just going along. So this concludes the first video, and I hope it gave you a good understanding and introduction in how to connect a server to an ESP and how to install and do your first baby steps in ESPHome to communicate with the ESP and have the server do the things that you want it to do. If you liked the video, please hit like and subscribe. I will be posting additional ones, and just come along with me and learn with me.